In this video, we're gonna look at why we use lipids. So we're gonna be continuing slightly about triglycerides and saturated versus unsaturated fats. We're also gonna be talking slightly about phospholipids, but more in a context of steroids. So why steroids can only pass through a phospholipid bilayer. So let's look at this really quickly. Now, from the previous video, we know that fatty acids, so lipids can only dissolve in non-polar substances. So they dissolve in non-polar substances, and that is because they themselves are non-polar. So alcohols are great at dissolving fats and stuff like that. And then we're now gonna talk mainly about why animals use triglycerides. So let's look at this. Uses of triglycerides. There are many uses, but the IB only wants you to know a few. So we're gonna have our first use, which is for energy, store of long-term energy. Our second use, which is insulation, and finally, not for phospholipids, but not for triglycerides, but for phospholipids, it allows membrane transport. So let's actually look through this syllabus real quick. So the first thing, long-term energy storage. We've already mentioned that triglycerides in animals are saturated. That's correct. So we're gonna erase this for a second. We're gonna write that it's saturated. Therefore, we can actually get a lot of energy, just like how we saw glycerol and how glycerol had a lot of energy packed into a small space. We can pack a lot of energy into a small space. So it's very, like, if we look through this, saturated fats can be packed super tight, and that means high energy availability. There we go. Yeah, so high energy availability once stored, which makes it a good source of long-term energy. And for insulation, we have firstly the main keyword you want to be using, which is adipose tissue, which is under the skin, so just like beneath skin, is just referring to the fat beneath your skin, and that actually bad conductor. So it lets us feel warm, and it's quite good for that. So this is the main use of triglycerides, and it's for animals and humans. Now we're gonna actually move on to steroids and hormones. So let's actually look at steroids quickly. Steroids. Now, steroids have a very complex structure that I'm actually going to use my book to draw, because you're not going to be tested on drawing them in the exam. So let's actually quickly look at a steroid. So steroids actually have a ring-like structure, and steroid hormones, actually I should write steroid hormones such as testosterone and it should be, yeah, ostradiol. So testosterone, ostradiol are both steroid hormones, and they have similar, like, their structures that look somewhat like this. So you have your rings, and this entire thing is actually non-polar. Now, going back to the last video, we also know that all fats, and especially in the phospholipid bilayer, there is a polar region, which is the head, and there's a non-polar region, which is the tail. So if we erase this, and we're going to start representing steroid hormones as like something that, yeah, let's just represent them as a load of triangles, right? So this is going to be our steroid hormone representation from now onwards. So we're actually going to look at why steroids can move through membranes. So we know that phospholipid bilayers look somewhat like this because there's a kink which comes from their tails being unsaturated, and then there's also another layer which goes like that. Right? Now we know that this is charged, so it actually has a negative charge. So we're going to say this has a negative charge, but inside there is no charge, which means that the steroids can actually move into this region and pass through, right? So that's what we are looking for. That's what we need to be looking for. That's why steroids can pass through a phospholipid bilayer, because both of them, let's actually use a different color for this. Non-polar, i.e. can pass through. So that pretty much sums up the entirety of lipids from B1.1. So just a quick overview. We're gonna raise this and draw a quick breakdown of everything we learned so far. We have learned about triglycerides. We've learned about phospholipids, which are amphipathic. We've learned about steroids. We've learned about the methyl group, methyl CH3, and the carbonyl COOH groups. Both of these groups are found in unsaturated fats. We've learned about cis versus trans unsaturated fats, and we've learned about saturated fats, which is in adipose tissue. So this is going to be pretty much all of the content on B1.1 for this examination: lipids and carbohydrates.